webinar on a series that we're running over next month. And we're doing it in conjunction with the ACA, our fellow industry stalwarts. This being our first one, we'll run through the housekeeping. You can leave your microphones on mute as long as you like, but if you do want to ask a question, be sure to touch the unmute button up the top of the screen if you're on a standard format. You might have to hunt around if you happen to be watching this on the phone. If you are shy, hit the Q&A button and it'll come up in the commentary feed, and we can sort them out and respond to them at the end of the webinar. Or if Nick sees that it's a red hot urgent topic, she might give us a shake and hold Nick Critchley's talking for the moment in order to respond to that question. I'm Graham Vile. I'm the current president of ACRA. It is a growing organisation, and we're really pleased with the sort of involvement we're getting from widely across the remedial industry now. Nick Critchley is our speaker from Marine and Civil Maintenance. I mentioned the word stalwart because MCM have been a stalwart of the remedial industry and heavily involved in ACA over the years under Alan Bird. And they're going from strength to strength, which is good to see. Nick will be talking about balancing the interactions of concrete demolition, containment and silicosis. It's a bugger of a thing to have to control all of that dust on site, and well, there are methods that Nick will talk about as to why we should implement them in order to manage the risk of silicosis for the workers. The world is constantly changing as we know it. It's been an exciting year for change. In the construction industry, there's the competing pressures of safety, environment and productivity at the forefront of the engineering team, and probably for the bean counters, it's what's the cost. We have to push back against cost and go for quality and safety. Nick's presentation he'll explore the context of demolition, how to manage the fly rock and dust in particular, in order to address the silicosis risk in the repair industry. Nick's got more than 18 years experience in infrastructure, asset maintenance, rehabilitation and protection roles. He's specialised in concrete, he's done a fair bit on timber and steel structure inspections as well, gone through the investigation processes and design strategies. He's also pushed into the implementation and refurbishment and protection processes on site. Nick's got a well-developed business strategy, and he also deals with bidding and contract admin type roles as well. During his career, he's worked in many fields in Australia and China. He's proven himself to be a successful collaborator for the teams, and whether it's in business management, development or project delivery. He's a relationship-based leader, and he's also a good-looking rooster. He empowers his teams to ensure the clients receive the greatest care. And I'll hand over to Nick.
Great. Thank you very much, Graham, for the kind introduction. And for those of you that have it running through your mind, the picture on the wall behind me is not me. It's Jeff Bezos from Amazon. I only say that because Nicole and Graham asked me that as soon as I got on the video call today. As Graham's detailed, I will be delivering a presentation on balancing the interaction of concrete demolition, containment and silicosis. And the presentation really captures parts of the information that are available via various safe work authorities in the States and also federally, as well as some of the learnings that as a company we've experienced over the last couple of years as we've learnt more and more about this relatively young issue. I talk about interaction in the presentation because there are some competing needs, particularly when you're considering concrete demolition. And, you know, from the safety perspective, You're looking at managing respiratory issues, eye injuries, crushing, pinching cuts. Environmentally, Graham mentioned, dust issues, which are a particular concern on, confined sites amongst high population. You've also got noise, vibration that can be an issue on those sites. And then these interact with production. And when I say production, it's, the speed at which you're able to undertake demolition activities. On to the next slide. So as background on silicosis, a lot of us will have seen articles in the news, particularly over the last couple of years that are quite alarming and tragic, and a lot of cases related to the kitchen benchtop industry that you can see on the presentation in front of you. The issue being that silicosis can cause chronic bronchitis, emphysema, acute silicosis, accelerated silicosis, chronic silicosis, chronic bronchitis, emphysema, lung cancer, kidney disease, amongst other things. So it's really quite a nasty illness, or variety of illnesses that can be caused due to this exposure to the respiratory dust. So to go back a step, what is silicosis? So it's a lung disease caused by breathing in these small particles of silica, which is a mineral found in sand, rock, and minerals such as quartz. It's a natural mineral. So it's found in reconstituted stone, granite and sandstone, but also other building materials such as concrete, bricks and mortar. And in my presentation today, I tend to focus more on the effects or the probable silicosis effects caused by demolition of concrete. How much crystalline silica is present depends on the material. So as an example there, the reconstituted stone that they use for these kitchen bench tops can have a content of up to 95%. And the issue is not the inert material, but it is when you perform things like cutting, grinding, drilling or polishing that cause the release of a really fine dust. The last dot point on that page was of interest to me, so I thought I'd include it for everyone here. But the first confirmed case of silicosis was identified in Italy in 2010 and in Australia in 2015. So it is a relatively new phenomenon. So expanding on where it's found, the engineered stone you can see at the top of the first table in the middle of the page. Fibre cement board with quite a large range in terms of content. Concrete, again, fairly large range, so 5 to 40%. And that range does offer its own difficulties in terms of controlling the hazard.
Sorry, can I just interrupt you for a moment?
Sure.
Can you just put your screen to full screen because we can actually see the next slide.
Okay. Full screen.
Just like the normal PowerPoint.
Is that better?
Yep.
Is that working for you?
Thank you.
Okay, cool, no problem. The size range of the dust is from very small to effectively invisible. So the comparison on the chart on the right side of the page sort of shows that a human hair measures between 17 and 180 micron, and some of these dust particles are much smaller than that. And in the context of PPE and full face respirators and people that want to have beards, that is also a significant thing. And I'll touch on that a little bit later in the presentation. So moving into concrete demolition techniques that we have available to us, and none of these will be particularly groundbreaking for the contractors and consultants on the line, but we obviously have hydro demolition, so ultra high pressure water, jackhammering, wire sawing, core drilling, percussive drilling, diamond sawing, and the last one being the time and corrosion mechanisms that keep all of our the remediation contractors and consultants in business. There is a variance in the level of dust created by these activities, and I've got a couple of videos of different techniques. The first one's hydro demolition, and these videos do have some sound, so whether that comes through or not, we will see. But here's the first video on hydro demolition. It goes into slow motion, so you can see this is one of these hydro demolition robots that's been installed below a fender beam on a wharf, and the ultra high pressure water blowing apart the concrete matrix. The second video is a contractor completing some drilling, and he's actually using a drill tip that has a vacuum extraction piece on it. So I'll press play on the video now, but you can see it's quite effective in terms of controlling dust. And the vacuum extraction hose, you can see, is just attached behind the chuck, and very effective. And the last video I've got is some slot cutting being performed for the installation of a CP system. Again, it's a shrouded grinder system, and you can see the vacuum hose coming through the bottom of the image here. I'll just press play on this one. So quite effective dust control on those on these techniques, but of course when you don't have these extraction and shroud systems in place, it can be, of course, a very different story. Okay, just switch to the next slide. Okay, so in terms of exposure limits, the workplace exposure standard for respirable crystalline silica is currently 0.05 milligrams per metre cube over a 8-hour time weighted average. Interestingly, this limit is currently being revised by Safe Work Australia, and as I trawled over some of the state-based safe working authorities, I noted that Safe Work New South Wales currently has 0.1 milligram per metre cube, which is the old limit as we understand it. So there is a little bit of variance between the states presently, but our understanding is that most will fall in line with the Safe Work Australia requirement of 0.05 milligram. Part of our responsibility as a person carrying out business is carrying out air monitoring of our activities. And that's something that we have done several rounds of at Marine and Civil. And that sampling, the way it's done is that we place a sampler on a worker's lapel, also on their shirt, within their breathing zone. So it's generally sort of just on their chest. And they wear that for their work day, and then that sampling head goes off for testing. We've done several rounds of testing with personnel doing different activities, different sites, different types of concrete, and unsurprisingly, we've had lots of different results, but certainly the results have indicated to us that exposure limits can be exceeded when carrying out common concrete cutting and demolition activities. I've included just some results from some recent testing that we completed. So the top table just sort of explains the people that were tested. So there were 4 people tested, couple of leading hands, couple of labourers, and a little bit of a description of what they're doing. So, you know, top guys, general supervision, and the middle 2 labourers are actually doing the physical drilling and grinding and jackhammering. So an activity you would expect to generate higher results. And the bottom person, again, it's more a supervision role. You can then see in the table below that the respirable quartz crystalline silica content amounts range from 0.1 up to 0.6. A couple of things to point out. These results were taken in New South Wales, so the exposure standards detailed as 0.1 milligram per metre cube, when in fact Safe Work is now recommending 0.05. And in the context of 0.05, we can see that one of the results is above the recommended limit. Now, that of course means that we need to implement other control measures to keep that worker safe throughout his workday. There's also a requirement for persons conducting business under the Workplace Health and Safety Regulation 2011 to do a variety of things. And some of them are fairly well common sense risk management type things that we need to do, but there's also others that I don't think everybody is aware of. So, you know, and the things that are listed based on the regulation are identifying the silica hazards, labelling hazardous chemicals, obtaining safety data sheets, keeping a register of hazardous chemicals, managing the risk, providing PPE. They're all normal risk management items. You then get into some of the more demanding aspects of managing silica on work sites, which is, you know, ensuring exposure standards are not exceeded, monitoring workplace air for silica, health monitoring for your workers, keeping records, keeping air monitoring records, that is, and keeping health monitoring records, and reviewing control measures. And just on those records, there's also a requirement to hold on to those records for a period of 30 years. So that's something to be aware of too. So I mentioned before the requirement to take a risk-based approach to managing silica on site. Our testing has indicated that exposure limits will be exceeded with some activities. So we certainly need to look at how we then control that hazard for our people. And looking at the risk-based matrix, we've obviously got substitution, and the example in the context of silica is sourcing the non-composite stone bench tops or looking at others. Isolation, so looking at how concrete demolition activities can be isolated from other activities, so for example enclosures. Engineering controls, which I touched on a little bit earlier with the videos that I included, but you know, obviously local exhaust, ventilation, water suppression as well. Administrative controls are quite important, so good housekeeping policies are very important. There's not much point in controlling dust at the tool really well if residual dust is falling onto the floor and then someone is coming along once a week and sweeping that up, particularly without any PPE, because it's likely the limits will be exceeded whilst they're doing that. And right down the bottom of the risk hierarchy, we have personal protective equipment, and I've got a few slides on the type of equipment that we are using to help us control this hazard.
Nick? Before you go on to your next slide, just in regards to the previous one, there is a question that's come through in regards to the MCN tests with range of up to 0.06 milligrams or square metre. Was this using a shrouded equipment or not?
Yes, yeah, it was. Yep. Because that was testing done in March, so it's quite recent testing, and all of our tools now have that sort of equipment on them. Any other questions, Nick, before I keep going?
That's it so far.
Okay.
Thank you.
Sorry, I just lost my way here. Okay, so isolation is the first thing that we would need to look at when we're considering the risk hierarchy. In general, the public are unlikely to be at risk due to silicosis, just because of the nature of their sort of walk-by exposure to our sites. However, you know, there are certainly some circumstances where an isolation control measure would be important, but typically these isolation control measures are provided for environmental reasons. The type of containment that we have available range from shade cloth to the more impermeable plastic sheeting that you can see on the scaffolding in the bottom left image. And we've also got some containment now that is designed around providing noise proofing for our sites, a little bit unrelated to the silicosis, but included anyway in the top left image. Engineering controls to mitigate the risk of the hazard. So what we have available on that front are these tools, and there are a lot of advancements on this front provided by the major suppliers of the industrial demolition equipment. You can see here I've got an example of a number of water cutting tools, so the water supplied to the core drill on the left, and then the saws on the in the right images. Nothing particularly new here. The advancements tend to come in around these vacuum shrouds, around the grinding equipment, and you can see some examples from Hilti on the left, but also from other contractors, other suppliers on the right. So they're typically available for most size of cut-off saws now, which is great. And based on the video that you saw, they're really effective. It's also been extended to drilling equipment. So there's a couple of different types of drilling shrouds that have been designed. The one on the left is essentially a retractable plastic tube. So as the drill bit goes into the concrete, the spring is compressed, there's a vacuum attached to it, and obviously that sucks the dust out. The one on the right, you're drilling through a vacuum ring attachment. And interestingly, that tool on the right, the bottom component of it is the actual vacuum. So it's not requiring an external vacuum source. I mentioned earlier when we saw the second video that there is also drill tips that are hollow inside that allow for the dust to be extracted down the middle of the tip while you're drilling. And they are improving as well. When they were initially released to market, they were not particularly good on the productivity side of things, but good on the containment side of things. That's now being balanced out somewhat. And you also have jackhammering equipment now being fitted with this type of equipment. So again, similar to the drilling sort of approach, you typically got either a vacuum ring or a shroud at the tip of the grinder, tip of the jackhammer, beg your pardon, being provided. As mentioned earlier, all of this is great, but equally there needs to be a fair bit of consideration given to housekeeping. So cleaning up after these demolition activities have occurred, and really thought needs to be given to wet cleaning or vacuuming with high efficiency particulate air filters to ensure that that risk is controlled. So right down the bottom of the risk hierarchy, we have PPE, and this is generally in the form of full face respirators. Coming back to my earlier comment that the dust particles are smaller than hair, if you're going to wear a full face respirator, and to do it effectively, you need to be clean shaven. Okay, if you're not clean shaven, the only alternative is to look at an air fed helmet, which is the image on the left. And what sort of protection can we expect from these types of ventilation equipment? Well, you can see the minimum required protection factor on the left of the chart. It's up to 10 with the fairly basic sort of dust mask and half face respirator, 50 through the air-fed helmet, 100 through the full face respirator, and 100 plus through a full face respirator with supplied air. So changes dramatically the level of protection you can expect to provide your workers. Touched on it earlier, but it is very important that the workers wear PPE correctly. Respirators come in different sizes, so it's important that the workers are measured up to get a mask that fits them. I mentioned being clean shaven. The image on the right gives you a feel for the size of a hair, so that's a bit of beard stubble, and then obviously the fibrous material that you're trying to keep out from entering someone's lungs. So you can see how that will not work without someone being clean shaven. The fitment of the masks is particularly important. We've also found that it's very important to train the workers on how to disassemble, reassemble the mask, to replace the filters, and also the disassemble for the purpose of cleaning, because the guys working in them, get dusty and sweaty. The masks do get dirty, and to clean them, you need to be able to take them apart. They do need to be cleaned in a water solution, less than 50 degrees, scrubbed with a soft brush and dried in clean air. So there is a particular way that they need to be cleaned to remain effective. And that actually concludes the presentation from my end.
Nice work, Nick. Thank you for that.
Thank you.
There was one comment just about the phrasing of silicosis being an issue that we've got to deal with. In the material supply side, it's been known for a little bit longer than that. I spent some time in the quarries back in the 80s.
Yep.
And they were putting scrubbers on their plants and dealing with dust control at production side.
Yep.
And Peter Dove made the comment about the abrasive blast industry for at least 20 years have been using a non-silica based consumables in the grit.
Yep.
So it's really like our construction industry has kind of gone, oh, crikeys, we are working in this space now and we've got to deal with it.
Yeah, no, absolutely. And, it still blows me away walking down the street and seeing guys cutting concrete with a demo saw, no extraction, the old dust mask half on. So it's still got a long way to go in the construction industry.
Yep, agree. So are there any other questions from the floor?
Yep, Peter Dove has also asked, do you use or adapt AS NZS 4361.1 Guide to Hazardous Paint Management, Part 1, Lead and Other Hazardous Metallic Pigments in Industrial Applications to establish exposure risk to workers and public containment design?
I can't say I've referred to that standard specifically, no.
But if there's a coating involved, you might get some samples taken.
Yeah, look, absolutely. If it was a coating job, we have guys that deal with that sort of area. But no, that's not my background. I've sort of dealt more so in the concrete side of things.
Right. Yep.
So Greg Zambezi, he's come through saying a number of clients, Greg Zambezi is from GHD, a number of clients are requesting staff have masks fittings by HSE trained staff.
Yep, absolutely. That's certainly part of getting the mask correctly fitted is having someone that's competent to do so.
Yep. Can't just buy them at Bunnings?
No, unfortunately not. Well, look,
unfortunately not.
You just run that risk, don't you, that the mask won't fit and won't be effective.
Yeah.
Greg has also asked, do you see this extending into the general industry?
I think so. Yeah, I think so. I mean, it's, in the context of sort of Safe Work Australia revising their limit or halving it, which is going to happen. And I think the states will fall in line with that. There's going to be further emphasis on making sure people are complying with this advised limit and keeping their workers safe.
For sure. And I think being aware of the 0.05 limit from Safe Work, you'd kind of be nuts not to adopt it now.
Yeah, yeah. Look, that's absolutely right. But look, I was doing a little bit of a refresher this morning just on the issue and having a look over the websites, and it is interesting that there's still differing information, differing limits. So you can see we're all trying to sort of catch up on it a little bit.
Yeah. Okay. In terms of overall cost for these extra things, I know that I often give the bean counters a bit of a bashing, but we are talking about safety. So have you got an idea? Does this add 5% or 7 or 2% to a job?
Look, I don't think it'd quite get to those levels, Graham. You know, off the top of my head, you know, maybe it's adding 1%, something like that.
Okay.
The masks aren't inexpensive. The health monitoring is not inexpensive, and of course the training and the compliance requires ongoing effort.
Yeah. And that's, you deal with that in toolbox talks whenever you're doing demolition, so it's a daily reminder, and then...
Yeah, a variety of mechanisms. You know, it's an induction requirement for us, briefing on that. You know, we do tend to toolbox it on a regular basis. And of course, day to day, our supervisors are policing that, you know, guys are wearing the masks that they've been issued with, because as we all know, it's just an ongoing battle to make sure people wear PPE properly.
Yes, that's it. Okay, well, if there aren't any other questions from the floor, let me just have a quick squeeze.
Wheel. Nick, please restate what AS or OH&S regs you are working to.
So the standard I referred to was the OH&S standard, Workplace Health and Safety Standard 2011 was where I took those items from, Chris.
And I think that, oh, no. Jim Mortlock has said it's probably the reduction in productivity associated with plant engineering controls that is the major cost implication.
Yeah, fair comment. Yep, it certainly can have an impact with certain activities.
Absolutely.
I think that's all that's come through.
Lovely. Testament to the detail in the presentation, Nick. Thank you.
No worries. I hope it was okay for everyone down the other end of the line.
Yeah, did where I'm sitting.
Okay.
So yeah, look, thank you for putting it together. I know it takes time to fit these sort of things into your usually busy schedule.
No problem.
With this, we are working with the ACA on these, so we've got our colleagues in the ACA joined up, and the next presentation, Blaine will be hopefully involved in the next one on the 24th of June, same time. We're doing a presentation, Dust Control in Construction, how we worked with the new respirable silica dust working exposure standard, and that's going to be presented by Martin Sterling from Hilti. So you might borrow some of your slides and put the white out on certain gadgets. You never know.
Absolutely.
So everybody most welcome to sign up for the next one and the one after that as well, but I'll introduce it at the end of the next webinar. So thank you all for your time. Nick, any final housekeeping things?
No, thanks ACRA and ACA for putting it on, and yeah, look, if anyone has some queries offline they'd like to speak to me or email me about, feel free to do so.
And we'll make sure that we pop this up on the ACRA YouTube channel and as well as the website. And I'm sure ACA will probably pop it up, a link on their website as well at some stage. Thank you so much.
Good stuff.
Thanks, guys.
Thanks. Bye.
Bye.